All right, so hello and welcome. Uh, in today is the second lecture of CCNA, Enterprise, and today's agenda basically, if I put it across, what all we are going to discuss. So the agenda is going to be having understanding about the again networking devices once more, networking devices that we use basically regularly, and then we will talk about OSI model, and in this OSI model we will also see lab and see how basically the packets are basically encapsulated, the data is encapsulated layer by layer, lab with the examples, right? So yeah, these are and if time permits, then we will also discuss about the IP addressing, which means the subnetting, right? So this is the agenda of the today's class. Now, when we talk about the networking devices, we previously, yesterday also we mentioned, right? The main networking devices that you would see in, day-to-day kind of network across multiple companies. Okay. Uh, Let me also show you some of the topology again, just to understand this. So network, uh, you know, devices in company network. This is just you click on images. I just want to show you like what all the devices primarily that you would see in the network, right? So maybe this one or whichever it is. So here we go. I hope you guys are able to see this screen as well.
Yep.
Perfect. You guys can suggest me, by the way, any topology that you like here, or probably, yeah, this is also good actually, but not with the connections. I just wanted to see with the connections, and probably this is fine with add-on, add-on devices. Yeah, so it's mix of, by the way. So in basically network, what all the devices that you would have, right? So the devices you can expect, uh, switch, so end machines and endpoints, and endpoints could be anything we already discussed, right? So endpoints, and then you have switches, you have routers, right, for the wired, and then you have access point. Now what is access point? We'll have a discussion on those components as well. We will have wireless controller, so wireless controller, and we call it now WLC, and then you will have firewalls. If it is IP telephony, then IP phones. Yeah, that again, IP phone, basically it is an endpoint, but these are the primarily, networking devices. Okay, these are the primarily networking devices. Now, basically what all endpoints. So if you see this topology, these devices, you see these are the endpoints. Okay, these are the endpoints, the computers, printers, laptops, isn't it? Servers, these all are endpoints, what you see. This is endpoints. This is endpoints. Yeah, you see, these all are the endpoints, isn't it? And then if you notice here, the endpoints are connected to where? You see this device, the endpoints are connected to the switch. So in other words, if I show you this topology, you see that these are the endpoints. We have endpoints connected to this switch. These are the endpoints we have connected to this switch. We have connected to this switch. How network grows actually? Think of that you have maybe 15 users in your company. Okay, so you need only one switch to connect because in one switch, you have 24 ports, isn't it? So all 24, once all 24 ports are occupied, let's say now the business grows and you have to hire more people. So obviously this switch cannot actually connect all the machines, isn't it? In that case, you have to add one more switch, right? And that is how your network grows. And you will keep on adding the endpoints, you will keep on adding the switches, and ultimately you will have endpoints connected to this switch, right? What is switch? We have discussed basically yesterday as well. Switch, the primary use of the switch is to expand local area network, right? It is a layer 2, which we are going to discuss about this OSI model. So it is a layer 2 that which understands the MAC address. So means whenever this switch receives any data from this endpoint, okay, switch is going to learn the MAC address, and based on the MAC address, it is going to forward the packet. It is going to forward the traffic. That is why I'm saying switch basically understands the MAC address. So don't worry, we'll have a lot of discussions about it. Okay, uh, gradually. We have also discussed whenever the devices communicate, the communication wise, right? So unicast, multicast, and broadcast. So either the communication would be unicast, if the either or the communication would be multicast, or it would be broadcast, right? So switch basically supports all unicast, multicast, and broadcast, right? And then we also discussed about three way of transmission as and how they transmit the data, right? So we have simplex we discussed yesterday, we have half duplex, we have full duplex, right? So the switch basically supports full duplex. Full duplex means it is good. Why it is good? If it is half duplex, to think of a scenario. Okay, let's say this device is connected to, okay, which device supports a half duplex? Anyone? And I would really request everyone actually to speak out to clear your doubts. Okay, it shouldn't be like where I am only talking and that's it. So I just want to make this session very interactive, uh, so that while even discussing, I mean, the few doubts which you have, that should also get cleared, side by side. And for that, yes, the two-way discussion is always important.
You said yesterday walkie-talkie is half duplex.
Right. uh do you guys heard about the device called hub? How many of you heard about this hub device?
Yes.
Yep. How many of you have heard about the hub device? So guys, if you're not speaking, then mute yourself. Okay. So hub is similar to the switch. Before switch, we used to have a hub that basically expands the local area network. It adds more number of machines, PCs to it. But some of the limitations with the hub, that it has maximum 12 ports, one. and it acts as a half duplex. So what happens in half duplex? So let's say if this machine, maybe PC1, PC2, PC3, PC4. See, if PC1 communicates with PC3, so that means PC1 is transmitting the data and PC3 is receiving the data, isn't it? Am I correct?
Yeah.
So since half duplex is what? Either it can send or receive at a time. So if this PC is transmitting the data, if 4 has to send some data to 1, it won't be able to do that. Why? Because as soon as it sends the data, the collision would happen. What is collision? Collision is in simple terminology, this device and this device, if they are half duplex, and when this device sends the data and this device also sends the data, ultimately the data would be collided here and this would be discarded, means no one would receive any data. This is called collision in the networking. Is it clear what is collision?
Yeah.
So the chances of the collision in the hub network is too much with all that limitations, right? And that is why we do not use this hub implementation at all. Okay, because we want what? Full duplex. We want a device to operate as a full duplex, isn't it? So that is the reason now we replaced what? We replaced this hub, okay, with
Switch.
perfect. We replaced this hub with switch. Okay, so you see that switch, basically what it does, it expands locally in a network, works in the full duplex. Basically it is both. It can be sent, the data can be sent and received, which is awesome, which is very good, isn't it? So that is how switch works. And apart from that, hub, it always does this broadcast. You see that it hub basically only supports broadcast, no unicast, no multicast, which is again a bad. If why it is bad? If the PC1 is a manager and the 3 are the employees, and if the PC1 wants to send let's say the termination letter to PC3, uh okay, let's not talk about all termination and all, but maybe the appraisal letter, okay, to PC3. So as soon as the switch as sorry not switch as soon as hub receives that data, it will broadcast to everyone. So ultimately everyone would get the appraisal later. Is it good? No, it's not, right? So why? Because the nature of hub is every time it only supports broadcast. Make sense? But switch is again intelligent device. It supports a unicast. Wherever it is required, it will do a unicast, or wherever it is required, it will do broadcast, isn't it? So that's about again switch. Where do we use switch? You see all those connections you see over here, they are connected to the switch, right? Now, just for your knowledge, it's not like the Cisco is only, manufacturing the switches. Cisco is only the one who manufactures the routers. No, there are other vendors as well that they manufacture. They have switches, they have routers, right? But yes, what certification normally we prefer, so we go for the Cisco because it is quite global and common as well, right? Any question from the switch? If someone asks what is switch, so I guess you guys would be able to answer, right? Similarly, router. So what is router? Router basically connects to different network. Okay, so I would say network devices, I would put here router and company network. So router basically, when we say it connects to different, this is how you see we represent router, and this is the picture of the router. You see, this is the picture of router, and the representation wise, this is how we represent it. It is bidirectional, right? Uh, this you see this is router. So when we talk about the connectivity wise, where does router, you know, we place, or where does router sit in the network? So the router basically, here we go. You see that? This is router, and what this router is doing, it is connecting this LAN with the WAN. This is where to network. This is LAN, this is WAN, and the device that connects LAN and WAN is the router. So ultimately, can we say this, that the router sits at the edge of the network,
Yeah.
right? So if you see this topology, which is in the paint, these are the routers, right? And this router normally acts as a gateway. What? Gateway. Gateway means this is the gateway to go outside of the network. This entire portion, what you see, this entire thing is your, this entire thing is local area network, LAN. And router basically connects this LAN and WAN. So where do you expect a router to be? At the edge of the network. Does it make sense, guys? So talking about the router again, some of the features. So in the OSI model, which layer router works? Layer 3. What is layer 3 network layer? Uh, I'm talking about this, right? 7 layers, right? 7, 6, 5, 4, 3, 2, 1. So you see that network layer, and this is where the router works. Where does switch work? Data link layer over here, right?
Yeah.
Apart from this, router is again, full duplex, so no problem at all. When it comes to the communication wise, it basically supports unicast and multicast, but it never supports broadcast. Okay, so the router basically, again, when it receives the data from, let's say, this PC, it will never broadcast to the WAN, but it will only send a unicast or multicast based on the environment. So we'll keep on discussing these devices as we go along, right? So since we would be talking mostly about the routers and switches, that is the reason actually I have brought this again topic. Access point and these other devices, we will, no worries, we'll discuss as we go along. Okay. So coming to the OSI model now, yesterday we had discussed, right, little bit of it, isn't it? Why OSI model was introduced, and I explained it was introduced basically because earlier days every vendor used to follow their own setup of rules, and because of that, the inter vendor communication was not possible, right? Let's say this is HP and this is IBM, for example. They were unable to talk to each other. This HP device won't talk to IBM or Apple or Nokia or any other devices. Okay, why? Because HP supports all different algorithm, all different policies, rules. IBM supports different, and that is the reason this became a global issue, and everyone contacted ISO. ISO is International Standard Organization. ISO introduced what? OSI model, and said, hey vendors, you all have to follow one policy, one model. And what is that model called? The OSI model. What this OSI model does, it doesn't actually help to transfer data at all, but it explains what it does. It just explains how the data transformation, how the data transfer happens between this machine and this machine. Think of this is PC and this is PC. So this OSI model, again, why I'm basically emphasizing on this particular statement, because people do think that OSI model actually transfers the data. No, it doesn't transfer, or it doesn't help to transfer the data, but it explains how the data is transmitted from one machine to another machine. Does it make sense, guys?
Yeah.
Perfect. So, and how does it explain? How does that OSI model explain? It explains with the help of all 7 layers. You guys remember we were talking about the seventh layer, which is the application, isn't it? Whenever you want to send the data, let's say I'll put it here, one machine and two machine basically. One becomes sender and then the other becomes receiver, right? If this machine has to send anything, right, it has to interact. The first thing that it has to do is it has to interact with the application layer. And I gave you the examples also. What examples? For example, if you want to access internet, you need browser, web browsers, isn't it? Web browsers are applications. If you want to send any file, you need Microsoft Office or any other vendor, where you, let's say for the Excel or for the PPT or for the doc or any file, right? You need it. If you want to listen to a music, you need MP3 player application. So in this device, right, there are thousands of applications. So what is application layer? Application layer basically provides the interface to interact with using the various applications. Now, this application that depends on what you are interacting with. If you are interacting with the internet, you need web browser. If you are sending an email, then you need email platform, isn't it? If you are listening to music, you need MP3 players, right? What else? If you want to play a game, let's say chess in your computer, how would you play? You need game application, you need chess application, right? So anything that you interact, right, or anything that you use to interact with, that is called application layer. And without application layer, you can't do anything, because this is just a hardware box. Let's say this is a brand new machine. If you don't have operating system in this brand new machine, you won't be able to use it at all. Or can you? Right? You won't be able to use it at all, isn't it?
Yeah.
So that's where the application is very important. Now, trust me, this OSI model is very important. Why? Because day-to-day life, when you start troubleshooting, when you start implementing the network, you always have to take the reference of this OSI model. It is very compulsory. Just remember this. Okay, it is very important. Am I clear, guys?
Yes.
Okay, so let's say when you later days, when you want to configure a router, for example, okay, you would access through the application. You would install maybe putty in this machine, and then using putty you will access the router, you will access the switch. So the application layer is basically, it provides the user interface. Now I would ask you a simple question. If in your mobile, if I ask you to calculate something, what application you would use? A calculator?
Calculator, yeah.
What if I delete that calculator application? Would you be able to calculate anything?
No.
So what this calculator is in your mobile doing? This is application. that gives you ability to calculate anything, isn't it?
Yeah.
Yeah.
So for everything, as I told you, in networking, in this basically machinery world, everything that you are doing on hardware is all based on the application. Does it make sense?
Yeah.
For example, operating system, right? The web browsers, MS Office, and etc. Okay, the next layer comes is the presentation layer. So now you know that, okay, application layer, you would use some of the utility to, do job. Then the next layer comes is the presentation layer. Now, yesterday as well, I was asking you the question, isn't it? If this host has a song and wants to, let's say it's me and it's you requested, hey, can you send me some, songs? Right? What I'll do is I'll download the songs and send it to you, isn't it? Okay, here we go. Maybe I will attach those songs and send it to you through email or whatever it is, right? How does this receiver know what file or what application I have to use to open this file? Getting my point? What I'm trying to say?
Means like suppose if I'm sending a PDF, we need a Adobe PDF, and if it is a like doc file, then MS Office. So that doc and PDF or JPG photograph, that is presentation.
JPG. Okay. Let's say you sent a photo
Yeah.
to a machine. How this receiver knows that I have to use this application to open this file? So what happens? What is the presentation layer? As the name itself says, present. What to present? So what it does actually, whatever application layer that sender is using here, okay, every application has what extension, isn't it? If it is a bootable file, then you have exe extension and so forth, and etc. Right? So every application has what extension, isn't it? Do you understand this, right? Every file, every application has its own extension.
Yeah.
So what is the job of the presentation layer is to add that extension. So for example, when you open this photo over here, it will add JPG. Okay, you are what you are sending what? Photographs. All right. You will this machine, right, will automatically add this extension. So when this receiver receives, it's know that okay, I have received JPG. That means it is what? It is a photo,
Yeah.
right? You say, let's say you have very good game, okay, and your friend requests, hey, can you send me that game? I want to install it in my machine. Okay, so game has, let's say it is a bootable file, isn't it? So you have exe extension, which is a bootable, isn't it? So as when this machine sends that bootable file or machine sends that file, it will add exe. So receiver knows that okay, this is exe, so that means I can install this file, right? So isn't it the presentation layer job is very pretty much simple and important, right? It makes basically data a human readable. How? By adding the extensions to the data, to the files, to the whatever you are transferring between two machines. Does it make sense, guys?
Yeah.
Perfect.
Sorry. Can you explain this again, please?
Presentation layer, right?
Yes, please. Yes. Sorry about that.
No problem. So what I said is anything that this machine is sending, it will ensure that what type of application has been used, right? At this sender end, the same application extension would be added while sending it. So if you are sending a Excel file to this machine, so you would, the extensions. Okay, here we go. Okay, let me just clear it out. And this, maybe close this. extensions. What are file extensions? Not image, but you see docs dot eml. Isn't it? These all are what? You see the extensions, format, Windows audio file. So this is the extension that you would use,
Okay.
right? So what
Mhm.
is the job of presentation layer? To make sure whatever you are sending from one machine to other machine, it will add that extension.
Oh, I understand that.
So that the receiver, when it receives, it knows that this is this format. This is the file format. Yeah. Apart from this, adding the extensions to it. Hold on, guys. 1 second. Yep. So apart from adding the extension and making that data human readable, what else presentation layer you see presents data in human readable includes coding and decoding. What is coding and decoding, guys? Yeah, what is coding and decoding?
Like for the safety of that data, we encrypt it. Or coding.
I would say converting analog to digital, digital to analog. Does it make sense?
Yeah, means
Okay.
converting an analog signal to 0 and 1 for
Mhm.
machine readable.
So what is analog? This
Analog
file, okay, can you tell me what is this? What the file that you see? Is it analog or digital?
Digital?
digital. Yeah.
Are you sure?
Yes.
Again, are you sure?
Yeah.
Okay. Then when I send this file to you guys,
Mm-hmm.
it will go through the wire or through the Wi-Fi, right?
Yeah.
Through, so would that be analog then? Is that?
That would be digital. It would be sent in like 0 and 1. It would be coded digital.
So 01 is digital or analog?
Digital.
Is it 01?
Is it not 0 1, but it is like our computer gets that machine. It can only understand the machine language, right? So it then presents it into this way. So that is the way it
Okay, let,
understands.
let me correct you here.
Yeah.
The machine, it has stored this file in its database is a digital, but when it presents it in the monitor, it is a analog.
Okay.
Does it
Oh,
make sense to
yeah.
everyone?
Okay.
So again, machine has, or this laptop has saved this file in its memory.
Mm-hmm.
There it is all digital because it is basically stored the file in chunks and bits and bytes, isn't it?
Yeah.
But this is the representation form. When you see this in the on this screen, the monitor, this is analog.
Okay.
So when you send this file from this laptop to another laptop, this presentation layer converts this analog to the digital and back and forth the digital when you receive it from digital to analog, because again 0 and 1 goes across the network, isn't it?
Yeah.
So apart from coding and decoding, it also does compression and decompression. What does that mean?
If file is big, we sometimes use compression. But
Yes, I believe we all are working professionals here, and everyone has compressed the file. Have you ever thought that where are we compressing it? Which layer it is doing this? So the answer is presentation layer. Next time, whenever you are compressing the file, trust me, you will remember that, okay, presentation layer is doing this compression and decompression,
Okay.
right? And apart from that, encryption and decryption, we all know what is encryption and decryption. To secure the data, right? It encrypts it, right? And then at the receiver and it decrypts it. Does it make sense, guys?
Yeah.
So that is the job of the presentation layer. These are the responsibilities of the presentation layer. All right. So we used application presentation layer, added that extension of that application, and then we have session layer. What that session says, what does that session means?
It maintains a session between two computers, two PCs, they are communicating. Like,
It maintains the session. Every application has a session time, right?
yeah.
What does that mean? That means if I open a file, any file over here, right? So this file, there are actually, let's say, banking file, pages. So there we have session timer, that if you're not doing in that particular page for, let's say, 30 second or 40 second or 1 minute, automatically the session would be over, isn't it?
Yeah.
So the session layer, the job of the session is, yes, to create a session between two applications, or two basically between source and destination, right?
Yeah.
Also, it maintains the session at the background, and that maintaining the session I was talking about, every basically session would have a default timer, or you can change the timer. Like banking sectors, they change the timer for 30 second or 1 minute, right? So that is the job of session layer. It basically initiate, maintain, and close the session between source and destination, dialog control between device and nodes. Pretty much straightforward. Yes or no?
Yeah.
Perfect.
Means if we are emailing, then our computer will choose like which port to use and where to send the traffic to, right? So creating a session.
Yeah, creating a session. Yes, correct.
Is this some kind of duration? For example, if I'm sending a data or an email or an attachment to somewhere else, so that the timing it going to that destination, it's the in between the time counts as a session layer.
Yes, that time comes in the session layer. And also, let's say you open to SDFC, SDFC bank.com. I don't know whether this is, yeah. So this page is open, right? Now, what happened? The session layer, what it did basically, it created this session between this basically browser and then the SDFC server. Okay. Now it will also at the background, it will maintain that session.
Yeah.
Okay. And once you basically remove this, it will also close this session. Once you remove this, it will close the session. This is one example. Another example, let's say in my laptop, I have, let's say, files saved in my laptop. It is saved in the laptop, but it is not open. So in order to open that file, what you would do, normally you would double click, right? So the file would get open. So now between this processor level and between this machine and this application, the session layer is working. It has opened. Now this file is open here. It is not going anywhere because the session layer is maintaining this session at the background. It will only when you close this, right? So closing is what? It's again sending an instruction to the processor saying, hey, close this file,
Okay.
right? So that all job happens in this session layer. Is it clear, guys?
Yes.
So far, whatever we have discussed, these 3 layers, there is no any change in the data. Means if you are sending any data, okay, this data would remain same, no changes in this. It is just that presentation layer would add extension to it, session layer would create a session, but nothing change would happen in the data. And that is why it is called PDU, protocol data unit. What do we call it? PDU, protocol data unit. Okay, protocol data unit. Now, what happens when the session layer hands over the data? Okay, so let me just clear off this nigga and put it here somewhere. Now, what happens basically? Let's say, for example, the data is, this is the data. Does it make sense? Or let's say, this is the data that you want to send. You have put it in Notepad, right? You wrote this message, and you are sending this basically file or anything to the receiver, source and destination again. So what happens as soon as, so this data would remain same for these 3 layers, but as soon as the transport layer receives this data, because the transport layer, you see the heart of OSI model, very important layer. Okay, so this transport layer actually, what it does, every transmission media that we have, what transmission media that we are using, let's say in the LAN, we are using Ethernet,
Yeah.
right? Or maybe fiber optic cable, or maybe serial interfaces, serial cables, isn't it?
Yeah.
So any transmission media that we use, they have a capacity as in how much data they can send it together, right? So let's say the size of this data is 5 MB. Okay, the size of this data is 5 MB. Now the 5 MB data cannot be transmitted between 2 machines together. If the sender won't be able to send this 5 MB together, so what is the option here then?
It will send it in fragments, in bits.
Right?
Hmm.
Okay, guys, let's take 10 minutes break, and then we'll continue the session. Yeah.
Yeah.
All right. Yep. So we were basically in the transport layer. So what I was saying, the entire data cannot be transmitted in one go. So what this transport layer does is basically, the first thing what it does, it basically breaks that entire data into segment. What is segment? Just like this, just breaking into segment like this. Breaking into segments like this, right? Like this. Breaking into a part, right? But is it like, is there any size that it breaks, or it basically breaks it randomly? What do you think?
There should be size.
There should be size, right? And what do we call that? We call it MSSs.
MSS.
Very, very important point from interview perspective. Maximum segment size,
Okay.
right? Maximum segment size. This is the maximum size that the transport layer can, divide the data or segment it. And what is the size of that MSS? Every segment the size of that segment is by default to 1460. So in interview, they ask what is MSS. So what is MSS? Maximum segment size. This is the size that the transport layer segments the data. They may ask what is the size. 1460 bytes. Just make a note of it.
This is
Is it
What is it a full form? MSS?
maximum segment size?
and this 1460 is the minimum segments.
This is the maximum segment.
Maximum, sorry. Okay.
Right? Okay. So ultimately the size of each segment. So first of all, what did you notice? You noticed segmentation, right? Isn't it? At the transport layer, when the data is received, the first thing what it does is the segmentation. After that segmentation, because the data is in nowhere in sequence, right? It also provides the sequence number to it. Right? This is one, second segment, third segment, fourth segment, fifth segment, sixth, seventh, like that. Why? To provide a sequence number?
Otherwise, it won't be in a readable form. If suppose one is before, two is before one, so it won't be proper.
Yes, so that receiver can reassemble it using the same sequence number. Does it make sense? That is why at the transport layer, it adds the sequence number as well. Okay. Apart from this, transport layer is also responsible, right, for end-to-end data transmission. What do you mean by end-to-end data transmission, guys?
Sender to receiver.
Anyone? What does it mean? End-to-end.
Means suppose if some packet drops, so it will again check and then again send it. So there is proper like end-to-end data transmission.
So if this sender sends any data to this machine, let's say this is a computer, this is another computer. So can we say end-to-end communication?
Yeah.
Yeah.
I thought you guys would say no. And the answer is no. Let's say 192.168.1.1. This is the IP address of this machine. 192.168.1.2. This is the IP address of this machine. Okay. Now, if I have a data or if I have anything, so do you think communicating with this machine 1.1 communicating with 1.2 is the end-to-end communication? And the answer is no. And why? Because in this hardware, there are thousands of services that you are running. Do you agree?
Yeah.
In this, even though if it is laptop or workstation or anything, right? But still, you are running thousands of services in this.
Mm-hmm.
Let me show you. I guess I should be able to services in PC, computer, I should say, computer. What is a service computer? Services available in computer. It's taking something else. Microsoft services. Microsoft services. That's it. It is still not what I wanted to,
Does
because
that mean
mine is lap. Actually, mine is Mac, and that is the reason I'm unable to show you that. Otherwise,
does that mean that we are using like email one service and internet surfing another, Google surfing is another service, and if we have does that mean by service that thing or something else?
no. This basically means you have MSC services, right? What is the command to check in the MSC services? Okay, here we go. I guess got it. Or maybe it is displaying again something else. Trade services, MSC services in Windows. Okay, service manager. Maybe this would actually show you. All right. Here we go. You see that these are the services. How many services you have like this? There are so many services running in this. Do you agree? Have you ever opened this NetStop service? Have you ever opened these services in your computer? I mean, just see Bluetooth, certificate, COM, connected, data sharing service. Thousands of services you are running in this, Windows machine. Now, end to end, one of the service, a popular service is HTTP. Yes. What? One of the popular service is HTTP. Do you agree? So the end-to-end communication is basically not communicating with 1.2, but communicating with the end service, which is HTTP. And how this end-to-end connection establishment happens. At the transport layer, it adds a source port and destination port. Source port and destination port. What is the port number, by the way? What is port? This is new concept, isn't it? That you are hearing. Right? This is the new concept that you are hearing. Yep. What is the port? Every service that you have seen here, you see that? They are using a certain number of ports. Port number, actually. It's a numeric value, port number. So let me take you that through port numbers. Port number list. More items. You see, a port is a virtual point, right, where network connections. A port is a numeric value. Every service has been given a port number, actually. And you see these port numbers. These are the very popular port numbers, by the way. Port number 20 and 21. This is used by service FTP, and port number 22 is used by SSH. Port number 53 is used by DNS. Port number 80 is used by HTTP. We every time browse it, isn't it? You see, we are browsing this, so we are using HTTP, isn't it? So what is the port number it is taking? Port number 80. Port number 1, 2, 3, 4, NDP, port number 179 or 443. There are so many ports actually. So let me types of ports. I hope you guys are actually making a note of it because this is very, very important as well. Okay. So these are the, you see the range of ports, you see, I wanted to open this document and finally I got it. So there are some well-known ports, and the well-known ports are those from 0 to 1023. Okay. Well-known ports basically, that we use day to day, not this, but I have showed you the document where we have port number 80 for HTTP, and these all are the well-known port numbers. And you should actually remember these port numbers as well as you go along with this training, right? There would be a day when you would really need what is the port number of this service. Getting my point? So you should know. Then you have registered port. Registered ports are basically from 1024 to 49151. Okay. Registered port basically, or you can say the system ports. And then you also have the private port numbers, the range of 49. You guys can make a note of it, or let me just put it in the group itself. That would make more sense. Okay. So these port numbers, this is what it is talking about. This document you see here, it is talking about end-to-end data transmission, right? End-to-end data transmission means transport layer adds source port and destination port. So the source port would be what? Source port would be here, any random port between this range. Source port is always a dynamic range, private port. Anything between this would be the source port. Not always, but most of the time. So let's say 49152. 49152 is the source port. What would be destination port? If you are accessing HTTP, then the destination port would be port number 80. Isn't it? So this is called end-to-end communication. Am I clear, guys? So whenever I open and browse it to, let's say, google.com, www.google.com. So what is happening ultimately? My laptop, okay, transport layer is creating, okay, assigning one source port. I will show you in the lab also. I will capture the packet and I'll show you. So it is adding send source port of this machine, and destination port would be, since it is HTTPS. What is the port number as HTTPS? Anyone? Port
83.
number 443. Come on, you all are networking guys,
Sorry. Yeah.
right? HTTP port number 80 and HTTPS port number 443. So it will add the destination port as a port 443. Am I clear, guys? This is called end-to-end communication. And then you have with the sequence number we already discussed. Okay. All right. It uses two protocol here. At the transport layer, it uses two protocol, TCP and UDP. What? TCP and UDP. What is the full form of TCP? Transmission Control Protocol. Transmission Control Protocol. Okay. What is the UDP? User Datagram Protocol. Now in interview, basically, they ask this question, what is the difference between TCP and UDP? and it is very important. I told you, right? Transport layer is the heart of actually the OSI model. So the TCP, transmission control protocol, first of all, it provides you the connection oriented connection oriented session. What does that mean, connection oriented session? Connection oriented session means if this sender wants to send any data to the receiver, it is not like immediately this sender will start sending data. No. There would be a connection establishment. This basically sender, the sender would initiate a connection. It will send a, uh, so this basically TCP also supports, I should mention here, three-way handshake. What is three-way handshake? Because TCP is a connection oriented, and in order to create that session, it supports three-way handshake. This is three-way handshake. So basically, sender will first notify by sending a SYN packet, or we call it synchronized packet. Okay, SYN packet. In SYN packet, it is sender would send the basic details like, hey, I have this much data. I want to send this is the file extension, and this is what it is, the data all about. Okay, I have this buffer, I have this much, size. All that would be information would be in SYN packet. When receiver receives that SYN packet from this sender from 1.1, receiver would send immediately acknowledgement of this SYN packet, that okay, the SYN packet is received, and here is my SYN packet. Here is my SYN packet. Means this is my detail. I have this much buffer size, I have this much data or capacity, all the details would be there in the SYN packet of receiver. So now sender and receiver both know each other's capability. And finally, the sender would send a final acknowledgement. Okay, that I have received your SYN, and this is where the session is established. Does it make sense? And this is called three-way handshake in TCP. It is very important, guys. Three-way handshake. They ask in interview, what is three-way handshake? You should know. What is difference between TCP and UDP? You should know.
In middle, the acknowledgement packet, does the receiver say that I am okay with the packet you are sending? That is the acknowledgement packet in the middle
The
one.
acknowledgement is that SYN packet is received, and this is the acknowledgement of that I have received your packet.
Okay, okay. Okay. And the last acknowledgement that I am also okay.
Is this acknowledgement that yes, I have also received your SYN
Okay, okay.
packet. SYN is basically synchronized packet. What is the full form? SYN, synchronize.
Yeah.
Is it clear? Three-way handshake. And this is called connection oriented, because every packet that this receiver receives, it will send an acknowledgement. But in UDP, what happens? UDP is connectionless. Okay, means there is no connection between sender and receiver. Does it make sense, guys? No three-way handshake. No three-way handshake. This is short form, by the way. No three-way handshake here in UDP. Is it clear so far?
Yeah.
Apart from this, now I'll give you one scenario. So let's say this three-way handshake is done here. Okay, we all know. I hope you guys are you guys have noted this in your notepad. I'll just remove this. So once the three-way handshake is done or connection is established between sender and receiver, what sender will do? Sender will send a packet. Hey, this is my first segment, right?
Yeah.
Yes or no?
Yeah. Yes.
So when this receiver receives the first segment, it will send an acknowledgement that I have received. When the sender sends the second packet, it will send an acknowledgement saying I have received it. When sender sends the third packet, it will send an acknowledgement. So what is this ultimately? This is the segment. This is the acknowledgement. Segment 2, acknowledgement 2. Here. Segment 3, acknowledgement 3. Sorry, it's here. Isn't it? So don't you think when the sender is sending the first segment or second segment, every time receiver has to send an acknowledgement, which is good, isn't it? This way it is confirmed that the data is received. But don't you think it is slow as well? It is making overall process slow,
Yeah.
right?
Yeah.
So to reduce that overall or to increase the or to reduce that delay, okay, there is something called here in transport layer in TCP windowing. What? Windowing. What is windowing? So windowing is basically a process of sending the multiple segments at one go. So what happens basically? Sender will send that packet, okay? Receiver would send a window size. Receiver will say, hey sender, you know what? This time I have very good buffer. You can send me, or the window size, it will send it when it sends a synchronized packet, right? While establishing the connection. That time itself, it will send the window size, saying that my window size is, let's say, window size is send me 3600 bytes. 3600 bytes. Okay. Then what sender would do? It will not send a segment 1, segment 2, segment 3. Or in other word, this receiver would say, send me 10 segments. So what basically sender will do? It will send 10 segments. Segment 1, segment 2, without acknowledgement. Segment 3, segment 9, segment 10, like this. Okay. Once the 10 segment is received, receiver would send final acknowledgement saying, yes, I have. This is my acknowledgement. I have received 10 segments. Now this time you send me 20 segments because I see the buffer size is free. I am free. And this has that capability. So this window size receiver will keep on setting it up every time. Okay. Based on how fast the processor is, how fast the resources is, how fast this machine is. Based on that, it will keep on setting the window size. Okay. And then sender will keep on sending, and then we'll wait for the final acknowledgement. Isn't it good feature?
Does that mean that suppose some data is there and then the receiver says that this size is okay, this size I could handle, right? Divide it into this segment, that is called windowing, means window size, and when it sends it, then it understand, like if it could handle more, then the sender increases the window size. Does it that mean that?
Receiver increases the window size, not
Receiver.
sender.
Okay, then it, okay, then receiver increases the window size, right?
Yes.
Yeah.
Okay. And apart from that, so I hope this window size is clear. Why we are doing window, why we are setting this window size, so that the process should be a little faster than one packet, one acknowledgement, second segment, second acknowledgement, like this. So ultimately this will delay the overall, process. If the sender takes normally, uh, let's say 10 minutes to transfer the file, by setting up the windowing, it will take like 3 minutes or two, if sender takes 10 minutes to transfer the file, by setting up the window, the sender would, only take 2 minutes or 1 minute of time. So it is good feature. Apart from that, there is one more feature called flow control, which TCP supports, UDP does not support. No flow control. What is flow control? I just now told you window size, right? What if this receiver is fully bombarded with the traffic? Maybe other machine also starts sending the data. Maybe third machine also starts sending data. So this machine now, ultimately the process level would get reduced, isn't it?
Yeah.
So this is where this receiver sends the window size 0. Window size 0 is why? Because if this sender keeps on sending the data, ultimately what would happen? This receiver would keep on dropping the data here itself, isn't it? Because it doesn't have buffer, it doesn't have resources to accept it. Does it make sense?
Yeah.
So what is flow control? This receiver would send a window size. In this situation, window size 0 means it is an instruction to the sender. Hey sender, stop sending data. Don't send any data to me, because I am currently, my buffer is completely full. To prevent the loss of data, we set the window size 0, and that is called flow control. Okay. In TCP, is it clear? The flow control, guys?
Yeah.
Perfect. There is also, so this is the difference between TCP and UDP. Okay, this is the difference between TCP and UDP. And as I told you, it is very important not to remember these differences, but to remember what is three-way handshake, what is windowing, how flow control works, right? Normally, TCP is used whenever you are sending the data, and UDP is used when you are sending audio or video. Why? Video. Because in TCP, there is something called TCP retransmission. What do we say? No one asked this question. What if sender sends the 10 segments, and let's say the 9th segment is dropped here. 9th segment is dropped means receiver didn't receive that 9th segment. Receiver received 1, 2, 2, 2, 8 and 10, but 9 is lost somewhere in the transit, somewhere in this middle. What will happen to that? So ultimately receiver, in this case, receiver would send an acknowledgement of 8, that I have received the data till 8 segments. You need to still send segment 9, right? So when sender receives that acknowledgement 8 from the receiver, sender knows that the 9th segment is lost and I have to retransmit it. So sender would send again or retransmit that packet or data to the receiver. That is called TCP retransmission. TCP retransmission. And this is the this is again the part of flow control itself. Is it clear what is TCP retransmission?
Yes.
If any data is lost, Raju, is it clear?
Yeah.
Darshan,
Yes, yes, yes. I mean,
Tanuja,
Clear, sir.
right? So this is the difference. Now I was telling you TCP normally TCP protocol is used whenever you are sending the data. UDP uses audio or video. Why? Because in audio and video, we do not need acknowledgement, isn't it? Even audio and video should be very fast response. So that is the reason UDP uses this audio and video, because there is no point of retransmitting the audio or video. Data is something, you know, that sometimes the internet connection is 3 MB, sometimes the internet connection is 10 MB, and packets are getting dropped in between. So the receiver would again, a sender would again send it. For example, you are downloading any site or anything from the google.com. Okay, what would happen while downloading? You see that there must be, you know, packets dropped in between, but sender, who is sender? Google is sender and your machine is receiver, right? Because you're downloading it from the Google. So from there, this TCP retransmission will keep on happening, because this is data and it is okay to retransmit it. Okay, coming back to now this. So this is what the transport layer is all about. Okay, discussed a lot. As soon as the data is received, it breaks into the segment, assigns the sequence number, right? And also it is responsible for the end-to-end endpoint and data transmission. That means at source port and destination port. And apart from that, you know, it supports TCP and UDP, two protocols at transport layer. You know what is difference between TCP and UDP. After this segment, what happens? That segment is handed over to the network layer. The segment is handed over to the network layer. So it is like this. Let me just remove all that. Need it. So what happened here? Let's say this was data. This is data. And then, so this is data means segment, one segment, isn't it? So you would at L4, either you would use TCP or UDP, isn't it? You would use TCP or UDP. So let's say if you are using TCP L4 segment, right? And in TCP, we have discussed source port and destination port, isn't it? Source port and destination port. For example, let's say source port is 1 and destination port is 2. For example, this is the segment at layer 4. Now what will happen? This would be handed over. So let me just copy this. Now what happens? This would be handed over to the network layer. Now what network layer would do? Network layer would add one more. So, network layer would add what?
Source, destination, and IP address and destination IP address.
So network layer is L3.
Yeah.
And it basically it will add the packet. It will add the packet. What does that packet means? It will add a packet header or network layer header. Packet means IP header. So you see, responsible to assign IP address and subnet mask. So as soon as the packet is added, that means the protocol that we use here is IP. The main protocol I'm talking about, IP. Okay. And IP means from where to where it has to go. Source IP and destination IP. So let's say source IP is 1.1. Okay. And destination IP is 2 here. Isn't it? So now every layer would add some information so that the data should be able to, reach from sender to receiver. This data is still there with the sender. Just remember, it hasn't gone send receiver yet. So network layer responsible to assign IP address and subnet mask, logical connection setup, data forwarding happens, routing and delivery error reporting, IP, ICMP. These are the protocols that it works in the network layer. We'll keep on discussing about these protocols and all. So ultimately, network layer adds the IP header because address. What happens when you send a courier, right? What happens when you go to the courier office? They'll ask you to mention the address, sender address and receiver address. Similarly, this data has to go from sender to receiver, but address is not there, isn't it? So now address is added. IP, source IP, destination IP. Now this data has two information, layer 4 and layer 3. Is it clear, guys? You remember we were talking about the router. Router works at the network layer. Router works at the network layer. Then this packet would be handed over to whom?
MAC address, data.
To the data link layer. So let me just do like this. It would be handed over to the
Layer.
data link layer. And what data link layer does? It will convert that packet into frame. Responsible to add MAC. So as soon as MAC gets added, it becomes a frame. So this layer 2, okay, would add frame, and frame means MAC address. MAC. And what MAC? Source MAC. Let's say source MAC is A and destination MAC, we don't have a space much, is B. Means this is MAC address A and this is MAC address B. Okay, MAC address A and MAC address B. So now local address, it has this data where to go. It has local address as well as the global address, and also which service in this machine it has to go. All that information this data has got, right? Data link layer, you see, responsible to add MAC address to the packet and convert to the frame. use LLC to find network layer protocol and then encapsulate them. So ultimately, I should say here it adds IP header. Here it adds Ethernet header. Okay. Here it adds TCP header. These three header you should know actually. So tomorrow when we meet, okay, we will discuss about this, which is there in the document also. In this document, we have basically other. Right. And then finally, this data link layer, once all the information is completed, then physical layer. And the physical layer, as you see, responsible to convert frame into bits. Convert frame into bits. Bits is nothing but 0 and 1 at the layer 1. Right? L1 bits. 0 and 1. And finally, now when this data has all that information, now the data will start traveling over this link. This is Ethernet link, 0 and 1, 0 and 1 like this. Is it clear, guys? Any question from this? Okay. So we have already discussed, by the way, but at the application layer, as you see, provides user interface so that we can interact with the different types of applications such as operating system, Internet Explorer, right? It allows the user to access, retrieve, and manage files in a remote computer. These are some of the protocols, okay, that works in the application layer. An interview, they ask actually, which layer DNS works, which layer HTTP works. Some of the very common and very important actually protocols that we use day to day, and we should really have idea about it. Okay, so like file transfer protocol, whenever we transfer the file between two machines, the protocol that works is FTP, performs basic interactive file transfer between hosts. Telnet enables user to execute terminal sessions with remote host. We'll keep on discussing those one by one. Okay, but just make a note of it or take a picture of it and try to remember those, these protocols, because these protocols are widely used. In interview, they might ask, okay, what is DNS, how it works? What is DHCP, how it works? What is FTP, right? What is SMTP, how it works? Isn't it? So you should have a very detailed knowledge on this. We will discuss, by the way. But yes, these are the protocols that works at the application layer. Presentation layer, it encodes, we have already discussed. Session layer, it basically creates the session, maintains, and then transport layer, we have already discussed this. The application layer includes the following functions. Oops, not application layer, maybe the transport layer, end-to-end delivery, port-to-port, reliable choosing TCP or UDP, error control, checksum, right? What is this error control checksum?
If some data is dropped, they will give a error
If
and then retransmit.
Yeah, so if the data is corrupted or there is an error, this transport layer is a machine, right? Because this is where the data is built, isn't it? Or segmented. So that who will recorrect it? The transport layer would correct it, and this is based on the checksum value. We'll discuss this as well. Network layer, right? We've discussed adds basically host to host or adds basically IP address, right? It performs routing as in uh, where to reach it, how to reach the destination. Data link layer, right? And then finally, physical layer. So anyways, I will provide this document as well to you guys. You just go through it. And if you have any question, just let me know. Okay, so yeah, any question from this? Tomorrow we'll see the demonstration. The lab part we haven't done because we spent enough actually in theory. Tomorrow we'll see in the lab part this OSI model again in the demonstration. Yeah, using the Wireshark. Wireshark is packet capture tool that we use actually to capture the packet from the machine. So we'll do this. We'll have more, detailed discussion on OSI model from the lab perspective or from the topology perspective. Okay, so I think that's it for today. With this,
The classes will be from Monday to Thursday, or yeah, like, or
Monday
Monday
to
Friday?
Friday.
Okay.
Any question, guys? Silence means no question. So if no question, then I'll stop sharing and close for the day.
Monday to Friday, right? The timing is the same at 7 p.m. at Indian time.
Yep, same, correct.
All right. Thank you very much.
All right, guys, then see you. Bye bye.